Hello, my name is Attila Sándor and this is a DIWICON podcast about gas network monitoring application. When we are talking about gas network monitoring, we are talking about the supervision of the entire gas transportation or even distribution network, and we are focusing to the pressure values rise through the network. People working for these network operator companies know that the worst situation is when something happened within the system and there's no available information. Just angry customers who demand to re-establish their service. Now we can see a typical gas pressure regulating station, a cabinet plant type. You can see similar facilities through all over the world. Probably you cannot see power or communication cables on the field. Yes, this is the biggest challenge because all the installed electronic devices have to be operated by batteries, and to make the situation too more difficult, the cabinet and the place around is explosion hazardous area. So you can install devices with only explosion-proof design. You can say it is impossible, but I can show you how easy to do it. The gas flow from the transportation pipeline comes from under the ground. This is a common facility with two rails. There are filters and two pressure regulators with pilot valves. That DIWICON field controller device is quite unique. It has explosion-proof design and uses its built-in batteries, not just for operating, but even for supplying the connected field sensors. In addition, all the collected data is transferred to the central database by using built-in GPS communication. And by the way, thanks to the optimized event-based communication, the internal power supply allows independent functioning of up to 5 years, depending on application, of course. The installation of the field system is quite simple. Our field controller, called Aladdin, is for collecting the process data. There are special low-power transducers installed in the cabinet. The DIWICON pressure transmitter is connected to the process by a simple T connection. Pressure transmitters are for measuring both the inlet and outlet pressures. In this case, the inlet pressure means the pressure of the transportation pipeline, while the outlet is the regulated one. The state of the pilot valve is sensed by the DIWICON position sensor. I mean sensors because the secondary rail has the same instruments. This signal is being active when the regulator switches from the primary rail to the secondary one because of any kind of process or supply-related failure. Now we can see a very similar process on a display of a SCADA application. All the collected and processed data is on the screen. This is a trend diagram of the pressures, and you can see the resolution is quite good. Well, let's see some of the benefits. First of all, the system provides a kind of remote presence. Then I would say it's not only easy to install, but easy to operate, and because it's quite autonomous. In addition, the supervise is online and documented. Online means that operators have every necessary information to make decisions in time, while documented means all the collected and processed data is stored and can be used anytime for analyzing purpose or even as a proof of the availability. All these useful features are for improving the service quality. And just to sum it up, let's repeat the main message. I think the final result is the optimized network operation, where all the necessary information is available without delay, where the troubleshooting time can be really short, and where the system operates by using the optimal parameters without unnecessary losses. Thank you for your attention. Bye bye.